Okay, so last one, fast one. Here's hoping, huh? Alright, truck pulls forward with 2 crates on it. So this is what we call a train, and what you need to know is that the thing that's the most important is that you know, hold on, I'm sorting my pens out here, that okay, so what you need to know is that I'm just going to go ahead and label these crates 1 and 2, okay? As we've discussed before, internal tensions cancel. So whatever, because this block is here, this rope has tension and pulls on block 2. But whatever tension 1 pulls on 2, 2 pulls on 1. Okay, whatever tension 2 pulls on the car pulls on 2. So these tensions are Newton's third law pairs. These are Newton's third law pairs here too, right? So we're really not going to deal in the vertical with this sort of problem because it's not experiencing any change in velocity here. Okay, so I mean, certainly I would have to draw it on a free body diagram, but all these things are balanced in the vertical, so just important to note that. All right, so the real business at hand is usually they want you to find acceleration with this thing and then tension in the different ropes, okay? So you've got several options. Just like with a pulley problem or anything else, you can sum on the whole system, right? So if I said sum of F equals MA, the M would be M1 plus M2 plus M car if I summed on that whole thing, right? And that would be the A of the whole system. So if I summed all the forces on that whole thing, and what would be true then is that these two would cancel, right? And there would be some engine on tires on road. There'd be some traction force here. Yeah. So so I could certainly do it that way. I could sum just on, let's get a good color. I could just sum on crate 1. All right, so if that were true, sum all the forces on crate 1, then it would only be M1, right? But the thing that's true in these is that the acceleration is the same on a train, and that's what this is. The acceleration of all the cars is the same, or the train comes off the rails or crashes or whatever. So whatever this acceleration is, it's the same as this one, right? I could sum on 2 and the sum of the forces on 2 would equal the mass of 2 times the acceleration of the system. Okay, so and of course I could sum on the car also. I don't think that's going to be what they're going to ask us to do. So let's look at it. They want the acceleration of everything. So let's see what we've got. A truck pulls with force F. So this whole thing is symbolic, which makes it a little bit dicey, a little harder. But if we, so I could do that, and then the last thing I could do, which is the thing I think is probably the best to do, is I could sum on any 2. Okay, so I'm going to take the eraser and I'm going to say, hey, I'm not going to, really? You're really just not going to let me erase anything? Oh, thank you. Okay, so I'm going to lose this because I don't think that they have any intention. Both crates, blah, blah, blah. Determine mu. So I do not think that we really have any information about the truck, and usually that's not a player in these things. So I think I'm going to lose. I think I'm going to lose all this, and we're just going to concentrate on the crates. We could sum on them individually, or we could sum on them as a unit, right? So if I did this, then the sum of all the forces on M1 plus M2 is going to equal M1 plus M2. Again, it's the acceleration of the system. Okay. Well, what good it does for us if we sum like this is this one, right? That tension right there goes away. All right. So there are no vertical forces. The internal tensions cancel. So on M1 and M2 together, there is only, right? There's only one force, and it is the force of tension to the right. So I'm going to say, if we stay with blue. So the net force on those two, and I mean I can go in here and the eraser just, sort of eliminate. So the net force on 1 plus 2 is the force tension to the right. The place people go down on this, guys, is that they don't include both masses. They just put an M down. All right, so that's good. So I like that. Oh, except I think I have made an error, because part of the problem is that I didn't draw my free body diagrams, right? Because I haven't included, I have not included, so there's the tension to the right, but there will also be friction on each of those crates, yeah? So that's a thing too. So, so the truth is that it's going to be force tension to the right, and then minus 2 times, since the crates are identical, right, mu mg. Yeah? Or I think probably it would be better to say, maybe we even say, not that it matters, but I think it sort of shows off what's happening better, to say mu 2mg, right? It doesn't matter where the 2 is mathematically. Okay, so here we are. That's good. And this M1 plus M2 is also just 2m. Okay, so because the masses are the same, it doesn't have to stay M1 plus M2. So we can just, call that equals 2m A of the system. Okay. All right. So that's great. And they do want us to find that A. So I think all we would have to do now is just divide by 2m. Right. And we've got A. So yay. Now the kicker is once you have A, you're in. So now I can get whatever I want. So let's say I'm going to sum right here. That's the left crate, right? So I'm going to say force friction, tension left is what they're calling this tension, right? And we're just looking on how it pulls That's just a name for it, right? We're just looking on how it pulls on crate 1, and it pulls on crate. The left string pulls to the right on crate 1. And then this part is balanced, right? So, so that's fine. And if indeed there is an acceleration, then these have to be unbalanced. So I should probably make this one longer. So 1, 2, and we'll just let that one be 2 here and 3 here. Yeah. So if I were looking sort of at an equality statement, I could say F tension left minus force friction equals MA. And I know A. Yeah. So it would be F tension left equals MA plus mu mg, right? That's what friction is, mu mg. And at that point, the right answer, and I'm not even going to go into it longer, is just putting A in right there, okay? So if I then wanted to go to the right crate, yeah, then again the vertical is balanced. The friction on the right crate should be the same amount because the right crate is the same mass. And then, but on the right crate, so there's friction, there's also tension left, yeah, force tension left, and there's force tension right. Okay, so if we were going to look at the right, this crate, it's very complicated. But if we look at the system, okay, then this in here cancels out, right? And so then we end up with, for the system, we end up with friction, which is of both of them. So I can just say the friction on M1 and M2. I can write it as one arrow if I want to, as long as I label it that. And then the force tension right, is pulling on the other side of that system, and then this part is balanced. And I'm just going to say right now that's enough for this one, because this one is really tough. So good job. That's enough.